So today I will demonstrate a linear regression simulation web application. This application allows us to input parameters to generate data and perform regression analysis and visualize the result. So for the parameter setup first, I will set the sample size on 100 and mean mu 0, variance 1, intercept, which is like the first beta, 2, and slope 3. And let's set the number of simulation 1000 times. Now I will click the generation data button to create the data. So during this process, the application used the data and then the y equation, which is y equals intercept plus beta times random generated x plus mu plus error. So once the data generation is complete, the first graph will appear. This graph shows the data point regression by blue dots here, and the fitted regression line represented by the red line. This graph allows us to get the distribution of the data of a scatter distribution and how well the regression model is fitted. The second graph is the histogram of the slope and intercept that we put on. So this graph shows the distribution of the slope, which is the blue one, and intercept, which is the yellow one from our simulation. So the blue line represents the observed slope, which means it's generated. So after the 1000 simulation, I put the real beta 1 exactly slope as 3, but it's close to 3.0, but it's actually 3.07, and for the intercepts it's close to 0, but we got 2.08. For hypothesis testing, let's choose I'll choose slope first and greater. So when the result appears, this will show the a p-value along with the observed slope and the hypothesized value. The p-value indicates the probability of the observed data given the null hypothesis is true or not. For example, if p-value is really small, then it means really small chance of obtaining the result is if the null hypothesis is true. So if generally if the p-value has to be 0.5%, I mean we can reject the null hypothesis, and so this slope is statistically determined from 0, but we can see the p-value is 0.413, so we don't reject the null hypothesis because actually we randomly generated the data. So lastly, for the confidence interval, I will choose slope and confidence level, let's say 95%, and calculate the confidence level result. So the confidence interval indicates the range, which we expect the parameters to lie with a certain level of confidence. For instance, if the confidence level is 2.9 and 3.06, then it would be 95% confident that the true slope line is within the stuff, and actually our true slope is 3, so it is within this line. Additionally, if the confidence interval does not equal 0, it indicates that the parameter is statistically significant. Thank you.